This is the answer key for empirical formulas, part 1. This first one we did in class, but I'm going to redo it here in case you need to see it again. Whenever we're looking at empirical formulas, an empirical formula is really just a simplest chemical formula. The ratios are always in their simplest whole number form. For empirical formulas for ionic compounds, that's likely the same as the true formula, but not necessarily for a covalent compound, which isn't always going to be in its simplest form. The empirical formula, though, is also known as a simplest formula. What we're always looking for is, the purpose is to find subscripts. Those subscripts equal a number of moles per formula, and it actually represents a mole ratio. Of elements in the compound. So when we're looking for something like this one, where we've got iron, sulfur, and oxygen, we're looking for the subscripts. We'll call them X, S, Y, O, Z. And we find that by getting the X to Y to Z ratio. So to do that, in this case we're given mass. So we're going to have to convert masses, 0.0134 grams of iron and 0.00769 grams of sulfur, and then finally 0.0115 grams of oxygen. We're going to have to convert each of these to moles. So our first step, convert grams to moles. Every 1 mole of iron is 55.8 grams. Every 1 mole of sulfur is 32.1 grams. And every 1 mole of oxygen is 16 grams. So this gives the values of 0.0134 grams divided by 55.8 is 2.40 times 10 to the negative 4th moles of iron. For sulfur, you get 2.39, which is actually, if I round, should be 2.40 times 10 to the negative 4th moles of sulfur. And for the oxygen, I end up with 7.19 times 10 to the negative 4th moles of oxygen. Now, we could write the chemical formula this way. This is the ratio. This number to this number to this number. But we generally, in chemistry, we prefer to have formulas that have simplest whole numbers, and this is not in simplest form. To get it in simplest form, we find the smallest value, which is 2.39 times 10 to the negative 4th, and we divide each quantity by that number. This one is obviously equal to itself, 1. So that would be 1 mole of sulfur. And divide this one also by 2.39 times 10 to the negative 4th. Also equals 1 mole of sulfur. 1 mole of oxygen, excuse me, and that's not true. That's 3 moles of oxygen and 1 mole of iron when we do the division. So this gives my ratio of subscripts. This would be Fe1 S1O3, which in standard format would be FeSO3, which is likely iron 3 sulfite. So in our next problem, we're going to find the empirical formula between the elements chromium and chlorine. This is with 32.8% chromium in this compound and 67.2% chlorine. Okay. Now, we don't have a percent to mole conversion. So what we have to do, if we have a percent, we're going to convert percent to mass and then mass to moles. Okay? So if we had a mass, we're going to convert mass directly to mole. If we have percent, we convert percentages to mass first and then to moles. We can do that pretty simply by assuming that we have a 100-gram sample. It doesn't matter what size sample we choose, but 100 is convenient. The law of definite composition states that regardless of the size of the sample, the ratio of the elements by mass is going to be the same, or the percentage is going to be the same. So one way to write this is that percent composition is constant for a compound. So we can assume any size sample and the percentage by mass is going to be the same regardless of what we choose. Why choose 100? If we choose 100 and we take 32.8% of that 100, that means we've got 32.8 grams of that substance. And if we take 67.2% of 100, that's 67.2 grams of chlorine. Convert to moles. 1 mole of chromium is 52 grams. 1 mole of chlorine is 35.5 grams. Okay, taking care of the division, our chromium, we're going to have 32.8 divided by 52 comes to 0.631 moles of chromium, and then 67.2 grams divided by 35.5 grams is 1.89 moles of chlorine. We then divide by the smaller, 0.631, divide each of them by that same number. This becomes 1. And this is 3. So our formula is CrCl3, which is likely chromium 3 chloride. All right, in our next example, we're going to have the element thallium, and we've got let's see. Here we are. We've got 0.463 grams of thallium. We've got 0.0544 grams of carbon. We've got 0.00685 grams of hydrogen. And we've got 0.0725 grams of oxygen. We're going to convert each of these to moles. We're starting with grams, so we have mass, Go to moles next. All right, so 1 mole of thallium is 204.4 grams. 1 mole carbon, 12 grams. 1 mole hydrogen, 1.01 grams, and 1 mole oxygen, 16 grams. Okay, so this gives us, canceling grams, this gives us 2.27 times 10 to the negative third, and that would be moles thallium. We've got 4.53 times 10 to the negative third moles carbon. We've got 6.78 to the negative third moles of hydrogen. And finally, with oxygen, we've got 4.53 times 10 to the negative third moles of oxygen. Okay, we choose the smallest value and divide by the rest by that number. So we're going to divide by 2.27 times 10 to the negative third. So this is going to equal 1. This is 2. This is 3. And this is going to be 2 again. So our formula for this is going to be TL C2 H3O2. Okay. And you can probably recognize that this is acetate. So the final answer, thallium 1 acetate. All right, we move on to number 4. We want to know the empirical formula for a compound that contains 67.1% zinc and the rest is oxygen. So this would be 100 minus 67.1. It's going to be 32.9%, and that would be oxygen. Okay, we're going to go from percent to mass to moles. Assume 100 grams. That gives us 67.1 grams of zinc and 32.9 grams of oxygen. Convert to moles, and that would be 1 mole zinc, 65.4 grams, 1 mole oxygen, and that would be 16 grams. So 67.1 divided by 65.4 comes to 1. That comes to 2. This gives the formula ZnO2. In this case, zinc typically has an oxidation state of +2. Oxygen in this case would have to be -1, so this is actually zinc peroxide. Peroxide is the form of oxygen with a -1 charge. Alright, number 5. Barium has a sample of a compound, and it has a mass or weighs 200 grams. Contains only carbon, hydrogen, oxygen, and nitrogen. Carbon, hydrogen, oxygen, and nitrogen. By analysis, he finds that 97.56 grams of carbon, 97.56 grams carbon, 4.878 grams of hydrogen, 52.03 grams of oxygen, and 45.53 grams of nitrogen. We have masses, so we convert straight to moles. 1 mole, 12.0 grams. 1 mole, 1.01 grams. 1 mole, 16.0 grams. And 1 mole, 14.0 grams. That gives, for carbon, that gives 8.13 moles. For the hydrogen, that gives 4.83 moles. For the oxygen, we have 3.25 moles, and for the nitrogen we have 3.25. Okay, we can see that 3.25 is the lowest value, so divide each by 3.25. Alright, so these two are going to be equal to 1. And then we've got 8.13 divided by 3.25 comes up to 2.5, and 4.83 divided by 3.25 is 1.5. It's 1.486. We want to make it 1.5. We're trying to get close to a whole number. Our problem here is that we have halves, and we don't know if we should, we're not following standard rounding rules here, because we don't know if from the compound standpoint of the atoms that are involved, should we round up to the nearest atom or down to the nearest atom, because we've got a half atom here. So to fix that, we're going to multiply by a number. We're going to increase the size of these, because these are not whole numbers, they need to be larger. And when we do that, what we will do is that we'll find the fraction 0.5 equals 1/2. Our denominator is 2, so we'll multiply everything here by 2. So this times 2 times 2 times 2 times 2. Now, if we had had something like a 0.3, that equals 1/3. Take the denominator, multiply everything by that. 1/4, 0.25, 1/5, 0.2, and so on. Okay, so you just find what fraction it is, multiply by the denominator. So we've got 2.5 times 2, that is 5. 1.5 times 2 is 3. 1 times 2 is 2, and 1 times 2 is 2. That gives me the ratio of C5, H3, O2, N2. Final answer. Okay, problem number 6. The characteristic odor of pineapple is due to the compound ethyl butyrate, which is an organic compound, which just means it contains carbon, which contains carbon, hydrogen, and oxygen. So we know we have carbon, hydrogen, and oxygen. If a sample of ethyl butyrate is known to contain 0.62069 grams of carbon, 0.103448 grams of hydrogen, and 0.275862 grams of oxygen, what's the empirical formula for the compound? Okay, so no different here. We multiply by 1 mole over the mole, divide by the molar mass is what we're doing. 12.0 grams to convert to moles. For carbon, hydrogen, and oxygen respectively. Alright, and we end up with, let's see, 0.62069. So we will divide each of these by this number, 1.72 times 10 to the negative 2. And this is 1. This one would be 3. And this one would be 6. So that gives the formula C3H6O. Problem number 7, we have 300 grams of a compound that contains only carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. And it's found to contain the exact same percentage of carbon as it has oxygen. The percentage of hydrogen is found to be, I'm going to give myself a little more room for this big number, is found to be 5.98823% hydrogen, and we know that carbon and oxygen are in the same percentage. So to find that, I'm going to come up above a little bit right here. We would say 100% minus 5.98823. That's a 3. And that equals 94.0118%. And of course, since this is the percent of carbon plus oxygen here, if we divide that by 2, we'll have their individual percentages. And that comes to 47.0059. Okay, so that means we have 47.0059% carbon, same thing for oxygen. Okay. Our next step, convert to mass. So So this is going to be 47.0059 grams of carbon, 5.98823 grams of hydrogen, and 47.0059 grams of oxygen. Convert to mass, to moles. 1 mole, 12 grams. 1 mole, 1.01 grams. And 1 mole, 16 grams. So this becomes 3.917 moles carbon, this is 5.9289 moles of hydrogen, and this is 3.917 moles carbon. We divide each of them by 3.917. One there. 5.9289 divided by 3.917. That is 1.5. So there we have our 0.5 again, so we're going to multiply everything by 2 to clear that fraction. So this becomes 2 moles carbon to 3 moles hydrogen to 2 moles oxygen, or C2H3O2. And that would be the final formula. Problem number 8. We have 200 grams of organic compound found to contain 83.884 grams of carbon, 10.486 grams of hydrogen, and 18.640 grams of oxygen. Convert from grams to moles. And for oxygen, 1 mole is 16 grams. Okay, so for carbon, doing the division, that comes to 6.99 moles carbon, 10.38 moles hydrogen, and 1.165 moles oxygen. Our smallest value is the oxygen, so 1.165, 1.165, and 1.165. So it's going to be 10.38 divided by 1.165. That's 8.9. We could probably say 9 there and get away with it. And 6.99 divided by 1.165 is exactly 6. So our ratio, we can't get any simpler than that, is C6H9O. Notice that the 200 grams here was not needed. Sometimes information's thrown in problems, like in real life, that we can find information, but we don't need that information to solve the problem. Last example, 300 grams of organic compound contains carbon, hydrogen, and oxygen again. It's found to contain 145.946 grams carbon, 24.3243 grams hydrogen, and the rest is oxygen. So that means we're going to have 300 grams total minus 145.946 grams minus 24.324 grams. So 300 minus 145.946 minus 24.324. I guess 129.73 grams. So that means we have 129.73 grams of oxygen. Convert our masses to moles. So this becomes 1.216 moles carbon. This is 24.3243. 1.01. This is 24.083 moles hydrogen, and then 129 divided by 16 is 8.1. This number up here is not right. 145.946 divided by 12. This is 12.1. 12.16 moles of carbon. Then divide by the smallest, which is the oxygen, 8.108, 8.108, and 8.108. That's 1. 24.083 divided by 8.108 is 3. And 12.16 divided by 8.108 is 1.5. So multiply by 2. Gives 3 for carbon, 6 for hydrogen, 2 for oxygen, so we get C3H6O2. Final answer.